Ako si Kevin at welcome nga pala sa klase ni Kevin. Ang aking i-discuss ngayon ay tungkol sa first law of thermodynamics. Tayo ay may tatlong objectives. Una, define the first law of thermodynamics. Pangalawa ay provide real-life example and application of first law of thermodynamics. And last is answer word problems regarding the first law of thermodynamics. Una sa lahat, ano nga ba ang first law of thermodynamics na kanina ko pa sinasabi? First law of thermodynamics states that within an isolated system, the total energy of the system is constant, even if energy has been converted from one form to another. It also states that energy cannot be created or destroyed, but merely converted from one form to another. The first law of thermodynamics is also known as the law of conservation. It means that the amount of energy before will always equal to the amount of energy after. With that, let's proceed to the real-life examples of the first law of thermodynamics. The first example is riding a bicycle. When you pedal a bike, your body uses chemical energy from the food you ate. This chemical energy is transformed into mechanical energy that makes the bike move. Another example is boiling water in an electric-powered kettle. When you plug an electric kettle, the electric energy goes into the heating element. This heating element converts electric energy to thermal energy, thus making the water boil. What have you noticed in these two examples? The two examples shows that the energy is not created nor destroyed, but merely converted from one form to another. In the first example, the chemical energy that is in your body is simply converted into a mechanical energy that makes the bike move. In the second example, the electric energy is converted into thermal energy that makes the water boil. Now, let's proceed on how to solve word problems regarding the first law of thermodynamics. In chemistry, the formula of first law of thermodynamics is delta U is equals to Q plus W, wherein delta U is the total change in internal energy of a system. Q is the heat exchange between the system and its surroundings, and W is the work done by or on the system. If Q is equals to positive, then the system absorbed the heat energy, or we call it endothermic process. If Q is equals to negative, then the system releases the heat energy, or exothermic process. If W is equals to positive, then work is done on the system. If W is equals to negative, then the work is done by the system. Take note of the underlined words such as absorb, releases, on, or by, since this term will help you on how to solve word problems regarding the first law of thermodynamics. Here's a sample problem. 250 joule of work is done on a system internal energy increases by 118 joule. How much energy is transferred as a heat? We're gonna use the formula delta U is equals to Q plus W. Since the work is done on a system, this means that the 250 joule is equals to positive. The total energy is positive because in the problem we can see that the total energy increased by 188 joule. In other words, it was absorbed. This leaves us with Q as a unknown. Since the Q is unknown, we were going to use the formula Q is equals to delta U plus W. And with this, let's plug in the given. This leaves us with Q is equal to 118 joule plus 250 joule. After that, we're just gonna add the two given. This leaves us with 438 joule. That's all from me. I hope you learned something new. And this is Klase ni Kevin.